Okay, welcome back to the second part of the video. Well, having understood the basics of how to use the for with the sequence like list, tuple, and string, as well as the usage of the for with the range function. Now let's try to deal with relatively more complicated programs. Okay, so at the end of the day, sooner or later, we'll have to deal with more complex programs. So I've listed a few, or rather three programs, which will help us to gain a better understanding of the application of the for, right? So the first question is to print sum of the even and odd numbers of the first n natural numbers. Okay, so if the value of n is 10, I'll have to store the sum of the odd numbers separately, and then I have to store the sum of the even numbers separately, right? So if we do a rough calculation, say you have the even numbers like 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, and then 20 plus 10 is 30. Okay, so I should have the sum of odd numbers from 1 to 10 is 30, and then even numbers 2 plus 4 is 6, sorry, 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, and then 16 plus 9 is 25. So I should get the correct output as 20, 30 and 25 respectively. 30 for the even numbers and 25 for the odd numbers, right? So let's start the program. Okay, now this time I need to have two variables to show the sum. One for the even numbers, hence I have named the variable as eSum. So eSum means sum for the even numbers. And then it's a good idea to be capitalizing the word in between so that the moment you look at it, it'll be easier for you to figure out the very purpose of the variable, right? But it's alright if you leave s as a lowercase. So why don't you assign eSum and OSum to 0? Now we can do this. So 0 becomes the value of OSum as well as eSum to start with, right? Now let's start the for loop. For I in range. So this will be like 1, 2, n plus 1. Okay? But I need the value of n, right? So press enter, the value of n will be 10. So the first value of I will be 1, and the last value of I will be n. Okay? So since the value of n is 10. And then I come here. Okay, so I now need to figure out whether that particular number is an even. If it's even, I need to store the sum in eSum. If it's odd, I need to store the sum in OSum. Okay, OSum. So the condition is if the value of I modulus 2 is equal to 0. If the condition is true, then this number is an even number. So I would like to store in eSum equal to eSum plus I. Okay? And then if we see, I'm done with the statement of the if. Okay? So I need to manually press the backspace, and then why don't you have the else. So I could do with else, because if it's not this, then it has to be that. If it's not this, it has to be just that. Okay? If you have a situation like this, then use if it's. If it's not this, it could be this or it could be that, then you have to use if this. Okay? If it's a case of like two sides of a coin, it has to be head, otherwise it has to be tail. Unless and until if it stays on its the stamp itself. Otherwise it either has to be head or it has to be tail. So in such situation you have to use the if else, right? For example, if you divide a number by 2, the remainder will either be 0 or 1. It cannot be 2. If it's 2, again it's divisible by 2. If the divisor is 3, then the remainder could either be 0 or 1 or 2. So in this particular case, you'll have to use if, elif, and then else. Okay? So if it's not even, then it better be, the or, right? So you have or sum equal to or sum plus, and then you have I. Over the years, many students, say, they ask us, so why do we have to write a sum again here? If you run the program, you will understand, right? So we'll run the program. Okay, so before this, I come back, I'm done with the body of 4, right? And then finally, once I am done with the entire process, the final statement will have to print the value of e sum as well as or sum. Okay, so print the sum of, okay, even numbers, right? Even numbers till okay, till n is, right? Let's leave a gap here. Okay, I don't have to. I'll just write here e sum, right? And then print the sum of odd numbers till, okay, n is or sum. Okay, so let's run the program and check. Remember, if we manage to run the program correctly, I should get the answer. Sum of even numbers till 10. Till 10 is 30. Sum of odd numbers till n is 25, right? So let's check. Okay, there you go. Sum of even numbers till 10 is 30. Sum of odd numbers till 10 is 25. So let's understand this, or we'll simplify the program, right? This is a little too much. Say, continue to 5. When I run the program, I get to see the answer is 6 and 9. This will let us understand the program a little simpler. So, I hope it works. Okay, so the value of I starts from 1, right? 1 modulus 2. 1 modulus 2, the remainder. 1, okay, divided by 2. It cannot be 2 times 1. So it has to be 2 times 0. 2 times 0 is how much? 0, and the remainder is 1. Right? So when I divide 1 by 2, the remainder is 1. Okay? I hope you got this. So the condition becomes false. If the condition becomes false, this statement will not be executed. This statement will be executed. So you have or sum value is 0 to start with. The value of I is how much? It is 1. Right? 1 plus 0 will be 1. And then I'm done with the body of 4. Again, the 4 loop restarts. The value of I will be 2. 2 modulus 2, the remainder is 0. Okay, the condition is true. If the condition is true, 2 will be added to 0, and then you will have 2. Okay, so 1 gets added to or sum, and 2 gets added to e sum. So the next value of I will be 3. Right? 3 modulus 2, the remainder will be 1. So the condition becomes false. Okay, so what happens here is the value of I is 3. Remember? 3. The value of or sum is 1. So 1 plus 3 will be how much? It will be 5. Okay? And then the next value of I will be 4. The next value of I will be 4. 4 modulus 2, the remainder is 0. So this has to be executed. So the value of I being 4, the value of e sum is how much? 2, right? Look at this. Okay, so 2 plus 4 will be 6. Alright? And then, finally, the value of I becomes 5, right? So 5 modulus 2. 5 modulus 2, is it 0? Answer is false. And then this will be executed, right? So the value of I being 5, how much? The value of I being, okay, 4, is it 4? The value of I, 5, right? And then, I think I did a little mistake here. Okay, 6 here, and then, this is 4, right? Sorry. 1, and then 1 plus 3 is 4, sorry, it's 4. And then finally when the value of I is 5, I made a mistake here, it has to be 1 plus 3 is 4, right? I've mistakenly written as 4. So when the last value of I is 5, the condition becomes false. Okay, so it comes here, 4 plus 5 will be, answer will be 9. Okay? So finally when the value of I becomes 6, that's when the group is over, and then I come out sum of even numbers till the value of n being 5 is E sum. E sum is 6. Sum of odd numbers till 5 is, or sum is 9, right? So this is how you should understand the program. As in when you run the program, just mark the values of the variables and then change it as per the statements, right? So I hope you understood this quite a simple program, right? Now let's move on to the next program, okay? Okay, what do we have next? Okay, the program E says, find the sum of the series. S is equal to 1 plus x squared plus x 3 till x raised to n. So this is a common site in arithmetic series, remember? So, if I need two values, okay? One for the value of x and then another value for the n. Now let's say if the value of x is 2, if the value of x is 2, if the value of n is 3, okay, then I should get the answers like this. 1 plus, okay, x is how much? 2, right? Plus 2 raised to 2 plus 2 raised to 3, okay? So the value of n is how much? The value of n is 3, the value of x is 2. So if I have the value of x is 2, if the value of n is 3, then I should get the sum of this particular series. Okay, so you should have the answer like 1 plus 2 raised to 2 is 4, 4 plus 8 is 12, 12 plus 3 is 15, right? So, did I get it right? 1 plus 2 is 3, 3 plus 4 is 7, I'm sorry, 3 plus 4 is 7, right, 7 plus 8 is 15, right? So, be it any value of x, be it any value of n, if you manage to write the program correctly, the answer should be spot on. You should be able to get the correct answer, right? So I hope you have understood the question, right? So if I enter the value of x is 2, if the value of n is 3, I should get the answer as 15, right? So let's write the program. So first things first, I need two variables, one for the x and another one for n, right? So x is equal to 2, we'll keep the value to a small value so that we'll be able to understand the program better. Okay, if it works for the smaller values, there shouldn't be any reason why it shouldn't work for the larger values. So the value of n is 3. If the value of n is 4, then I should move on till plus 2 raised to 4. Okay? Now be careful, this is a little complicated. So pay extra attention. I'll move this a little up. Okay, let's get started. So again, I should have the variable of sum. I need to store the successive sum of these individual the numbers. Okay? Now think properly. For I in range, what should be the starting number? Now this is important. What should be the starting number? Should the starting number be 1 or should it be 0? Okay? So the I value will be like this. The value of I, look at this, 2, 3, and then can I say like you have 1 here, can I say like I have 0 here, right? So the value of I will assume the value of exponent, because if you look at the series, what changes is not the value of x, rather the value of n. The value of n has to change, from 0, 1, 2, and 3. Okay? So the loop variable understandably changes. With each completion of the loop, the value of I changes. And then what changes in the arithmetic series is not the x, rather the value of n. Okay? N being 3, it has to move on till 3, but it has to start from 0, 1, 2, and 3. So this is the reason why I'm using the loop variable of I for the exponent. Okay, let's go slow. So it has to start from 0, and then it has to the upper limit has to be n plus 1. I hope you're okay with this. Okay, press enter. Now let's store the sum. Sum is equal to sum plus, and then you have x. Remember, 2 multiplication symbol means the exponent, right? So x raised to I. Okay, so the value of sum is 0. I need to get this first. Remember? So the value of x is 2. The value of x is how much? 2. 2 raised to I. The value of I is how much? 0. So anything raised to 0 has to be 1. Okay? So I get the first value of the arithmetic series, which is 1. Okay? I hope you got this right. Because I need to first include this as a part of my sum. So I need to get the value of 1. Right? So sum plus the value of x is how much? 2. That will remain constant. Alright? So 2 raised to, since the value of I is 0 to start with, 2 raised to 0 is 1. 1 plus sum is 0. 0 plus 1, 1 becomes the new value of sum. So I got this. Okay? This is now saved in the sum. Right? Now next up is I need to get this. Okay, go up. The next value of I is how much? 1. The next value of I is 1. And then in sum I have 1 already. Remember? I think it's better if I make some space. Okay, so initially it is 0 plus 2 raised to 0, and then you have 1 here. Now next the value of I will be how much? 1. Okay? 1, and then it will be the value of x will be 2. The value of x will be 2. The value of I is how much? 1. Okay? And then what is the latest value of sum? It's not 0, it is 1. Okay? See this? So this time 1 plus 2 raised to 1 is 3. Alright? And then the value of I will now be how much? It will be 2. The next value of I is 2. Right? So 2 raised to 2. Okay, and the latest value of sum is how much? 3. Right? So 3 plus 4 is 7. Okay, and then finally, the value of I will be 3. 3 plus 1 is 4. 4 is not included, so 3 will be the last value of the loop variable of I. Okay, so the I is 3 now. Okay, so you have plus sign here. X will be 2 as usual. What is the value of I? The value of I is 3. Okay, so 2 raised to 3 is 8. The latest value of sum is 7. 7 plus 2 is 9. Okay, so this is how the program executes. Right? So let's get rid of this. So finally your answer should be how much? It should be 9. Right? So let's print the value and check whether we get the right result or not. So okay, so come this side and then print the sum is equal to, and then you have your sum, right? Just get this up. Okay, let's run it. Okay, there you go. I get the current value of sum as 15, right? So likewise, if you keep on changing this, say 3, and then if I have 5, then it means 1 plus 3 raised to 1 plus 3 raised to 2, 3 raised to 3, 3 raised to 4, 3 raised to 5. Okay? So once you get the program right, you will for sure get the right answer. Okay? So you keep on changing the value, you will get the correct answer, right? So I hope you got this. Now let's move on to the next question, the final question, right? All right. This is the most complicated of all the programs. Okay. But before I start the program, I so hope that you know the meaning of LCM and GCD, right? HCF or LCM, right? But it's important that I show LCM and HCF, otherwise you may have forgotten, right? Sure, you must have learned in the junior classes. Let's understand this. 10 and 15. You have two numbers as 10 and 15. What is meant by HCF? HCF means highest common factor. Factor means a number which when divides 10, the remainder will be 0. So the factors of 10 are 0, 2, 5, and 10. So this is factor, right? I know you know it, but just a matter of a reminder. So factor means we're talking about the numbers which can divide 10 if the remainder turns out to be 0, those are the factors. Okay, so likewise 15, 0, 3, 5, and then the 15th inside. So these numbers are the factors of 15. So a common means, highest common factor means it should be a number. I guess it should be 5. Okay, so this 5 is the highest common factor. Common factor means applicable to 10 and 15, both of them, right? So even though you have common factors like 1, okay? If you divide 10 by 1, you will get the remainder as 0. If you divide 15 by 1, you will get the remainder as 0. This is a common factor, but is it a highest common factor? The answer is no. Okay, so 5 is the highest common factor. Lowest common multiple. So greatest common divisor or HCF means the same thing. Greatest common divisor or HCF means the same thing. 5 is the greatest common divisor or the highest common factor means the same thing. LCM means the numbers which are divisible by 10. The multiples of 10 are numbers which are divisible by 10. Okay? It could be 10 itself, 20, 30, 40, these are nothing but multiples of 10. 15, 30, 45, 60, so on and so forth. These are multiples. So multiples means on the higher side of that number, factors means on the lower side of that number. Okay? This is very important. You need to get this, otherwise you won't be able to write the program, right? So, okay, now the logic of the program is, now let's say, look at this. I want to print, the highest common factor of 10 and 15, okay? I want to find the highest common factor of 10 and 15. The highest possible common factor will be the smaller of the two numbers. For example, if I have 10 and 20, okay, the highest common factor could be the smaller of the two numbers, which is 10 in this case. Can it be 11, 12, 30? It cannot be. Common factor means that particular number should be either equal to the smaller of the two or less than the smaller of the two, right? So that's for sure. If it's 10 and 20, it has to be 10, otherwise it has to be below 10. And then 10 and 15, it has to be 10 or it has to be below 10, highest common factor, right? So the first step is I figure out which is the smaller number of the two, okay? Because once I get the smaller number of the two, the common factor cannot be greater than the smaller of the two, right? So let's do the program. Okay, let's say I have the value of x as 10 and then the value of x as 15. We'll keep it simple, right? So, okay, something like this. Now let's continue further. Make some space. Okay. This has to be like, sorry. Okay, first I check which of these two numbers are smaller. But as of now, since the numbers are predefined, it's easy to pick up 10. But if you have the int input statement, the numbers could be randomly entered. So you never know whether x is smaller or y is smaller, right? So if x is less than y, then the smaller value will be x. Okay? If it's not, then you have x smaller. Okay? Smaller will be y. Okay? So I hope you got the reason why I am checking out the smaller of the two. Okay? 10 and 20. It has to be, the common factor has to be 10 or below 10, right? And then, now the next step is, now once I figure out whichever is smaller, that value will be assigned to smaller, right? And then I run a loop for I in and then range, right? The starting number has to be 1. Understandably, the first number has to be 1. I'll tell you the reason a little later. And then it has to move on till smaller plus 1. Okay? So you know the reason, right? So it cannot be, you cannot just stop at 10, it has to move on till 11, right? Okay. Now this condition is important. As of this, the highest common factor is how much? It's 5, right? So if a certain number has to qualify for the common factor of these two, the condition is this 10 should be divisible by 5. At the same time, 20 should also be divisible by 5. So this is a very important condition, right? Why do you say f is a common factor? If you divide 10 by 5, the remainder is 0. At the same time, 20, when it's divided by 5, the remainder will be 0. For example, look at this 4. Okay? This 4 is not a common factor because if you divide 10 by 4, the remainder is 2. But if you divide 20 by 4, the remainder is 0. This is a factor of 20, but it's not a common factor of both 10 and 20. So we have to use the AND operator in between. That's important, right? So let's just check out. You have if, right? If the value of x is divisible by I, right? And, if the remainder turns out to be 0, AND operator y modulus I is equal to 0. If the condition is true, look at that, this is x and this is y, 10 and 10. And then the value of I start from 1. If the condition is true, then what I do is HCF equals the value of I. Okay, so now let's check how it runs. Okay, let's do this real quick. The value of I start from how much? 1, right? X is how much? 10. X is 10 and Y is 15. 10 divided by 1, the remainder is 0. 15 divided by 1, the remainder is 0. Both the conditions are true. Very good. The value of I, which is 1, becomes the value of HCF. Okay, which is not true. But just hang on, the program is not over, right? So again, it goes back, the value of I will now be 2. Okay, the value of I will now be 2. 10 divided by 2, the remainder is 0. Good. However, 15 divided by 2, the remainder is not 0. So you have true and false, the overall condition will be false. So 2 will not become the value of HCF. And then the value of I changes to 3. 10 modulus 3, the remainder is not 0. Okay, so false and true. Overall condition is false. This will not be executed. HCF will still have the value of 1. Okay, I hope you got this. And then the value of I becomes 4. Okay, small is how much it is? Smaller is 10, right? 10 plus 1 is 11. So the last value will be 10. So this will go on. Now say when the value of I is 4, again, this will be false, this will be false. The value of HCF would still be 1. Now be careful. When the value of I becomes 5, when the value of I becomes 5, x 10 modulus 5, the remainder is 0. 15 modulus 5, the remainder is 0. So you have true and true. The overall condition will be true. So the I value of 5 will now become the latest value of HCF. Try for 6. This will be false. One of these two will be false. Or both 7, 8, 9, 10. Okay. So when the value of I is 6, 7, 8, 9, 10, none of the combination of these two numbers will give rise to the overall condition or both the condition to be true. So when the value of I is 5, both the conditions will be true. Hence, the value of I, which is 5, will become the latest value or the last value of HCF. Right? So this is how we get the correct answer, right? Of, let's say, 5, right? Now, how do you get the LCM is, there is a formula. Say, currently we are using this, right? The LCM could be calculated as x multiplied by y and then divide by HCF. Okay, this is the formula. I don't know whether you remember. So x multiplied by 5 is how much? 10 multiplied by 15 is 150. 50 divided by the value of HCF is how much? 5, right? Okay. So 150 divided by 5, you will get the answer as 30. So the 30 will be the LCM, lowest common multiple. Okay, you have 30 here. 30 is divisible by 10, 30 is divisible by 15. So this is the lowest common multiple. If you consider 60, it's a common multiple, but it's not a lowest common multiple, right? So 30 should be the answer if you apply this formula, right? So once you get the HCF, the LCM should be a big 1, right? So come here. Okay, I now got the HCF. Now calculate LCM is equal to, how do you calculate? Like I said, x multiplied by, okay, you have y and then divided by HCF, right? So once I'm finished with this, now this is important, otherwise, okay, now here it shouldn't matter. Finally, you have the print statement, right? Print HCF, okay, HCF is equal to HCF, and then finally print, you have LCM is equal to, you have LCM, right? So I hope you have understood the program. Now let's check whether the program runs correctly or not. Okay, so look up. Okay, let's run the program. Okay, there you go. You get the right answer as 5 and 30. Alright, 5 is the HCF and 30 is the LCM, right? So likewise, you can try for other numbers. For example, if I have 20 here, okay, so the highest common factor has to be 5, and then the lowest common multiple will be 60, I guess. Okay, it cannot be 40. 60 is divisible by 20. 60 is divisible by 15, right? So for the value of x is 20, for the value of I as 15, the highest common factor has to be 5, lowest common multiple has to be 60, right? So hopefully I get the right answer. Okay, there you go. And then let's try for one more number. Say, if I change this to 30, right? So the highest common factor has to be 10, right? And the lowest common multiple will be how much? Again, I think it will be 60. So I think it's 10 and 60, right? So this is, how you write programs for finding HCF and LCM. Okay, so with this we have come to the end of today's lesson. Now the most important thing to be noted here is you need to read the program again and again till the point you are totally comfortable with the understanding of the logic which is used behind the program. Otherwise, if you just read it and then have a rough understanding of it and then just leave it, it's not going to work. You must read the program again and again to such a degree that you feel confident or comfortable with the logic, and then slowly try to write the program, if possibly on the computer itself, right? So with this, I would like to wind up here, and then for the next week we'll be again continuing further with the next the iteration statements, that is the while. Okay, till then, take care and study hard.